This is video on friction. This is sixth video in the series. First video deals with the basics, and remaining videos we are trying to do different type of problems. So here in video 5 we are doing problems where dimension of the body is given. That is, we are required to use sigma fx0, sigma fy0 and sigma m0. Have a look. Problem says that a 7-meter long ladder rests against a vertical wall and on the floor, other side. Now, ladder makes an angle of 45 degree. If a man whose weight is 1/2 of that of the ladder, see, weight of the ladder is W, then man's weight is W by 2, climbs it. At what distance along the ladder will he be when the ladder is about to slip? The coefficient of friction between the ladder and the wall is 1/3, and that between the ladder and the floor is half. Now let's draw the free body. At wall, let there be reaction R1. At floor, let there be reaction R2. W and W2 are already there. Now note the friction directions. Ladder is about to slip. So this point, bottom point, wants to move towards left. Friction will oppose it. So this is the direction. And the magnitude is mu r, half R2. Similarly, here this point, see, ladder wants to slip. So this point wants to go down, so friction opposes it, and this friction will be 1/3 R1. Now, because dimensions of the body are given, we have to consider three equations. You see, now here rotation comes into the picture. So, first equation, right, sigma fx0 is simply r by 2, that is 0.5 R2 minus R1 is 0. Second equation is R2 plus R1 by 3 minus W2 is 0. And in third equation, we will take moment of all the forces about this bottom point. So that will be this W into horizontal distance 3.5 cos 45. Then W by 2 into corresponding horizontal distance. Let the man be at a distance L along the ladder. So then it will be L cos 45. Then this R1 into the vertical distance, that is 7 sin 45, and this R1 by 3 into horizontal distance, that is 7 cos 45 is equal to 0. This is equation 3. Now these three equations will be able to solve for L, and that L will come as 5. It is very easy to solve this. Now what it means is, when this man climbs up the ladder up to L, that is up to 5 meter, he is okay. But when it comes to 5 meter, ladder is about to slip, and if he exceeds 5 meter, it will actually slip and he will fall down. So this was what is the special about this type is we use three equations. If you see previous videos, dimensions of the body were not given. So rotation about its center of gravity is not considered, and therefore we only use sigma fx0, sigma fy0. See one more problem. A semicircular disk of weight W is resting on a rough horizontal plane whose coefficient of friction is 0.1. It is being pulled by a horizontal force P applied along its diameter AB, just enough to cause sliding. Find the inclination theta of the equilibrium configuration. See what happens if you actually try to do this experiment. Before it moves further, it rotates by angle theta, and we are to find angle theta. Now here the radius of the disk is given, so we are going to use three equations as we had done in the previous problem. Let's do the free body. See, of this equilibrium configuration, this is P R1 and friction opposes it, so 0.1 R1. Now let's do a little bit of geometry. Centroid of this disk is at 4R by 3, and at this point the weight W of the disk will act, and this angle, the rotation is theta, so this angle will also be theta. let this distance be x and let this height be y. Now let's write our sigma fx equation, sigma fy equation and sigma m equation. P minus 0.1 r1 is sigma fx equal to 0. W minus r1 is sigma fy equal to 0. And taking moment about this point, w into x minus p into this vertical distance y will be equal to 0. These three equations. Now from geometry, we can easily see that this x is 4r by 3 pi sine theta and this y is total r minus this r sine theta. So this is y. If you put in here, and you will be able to solve for theta, and we will get that theta for equilibrium configuration as theta equal to 11 degree. Thank you.